Hey everybody. We're going to try something here, doing video notes. I would encourage you, if you are trying to take notes and it's going too fast, pause the video. That way you can get caught up with what we have going on. So what we're looking at today is absolute value functions. We're going to start looking at what the graph characteristics are of that, and then move on to how transformations of the function occur and how that changes our graph characteristics. So first we're going to look at the parent function of absolute value. So our absolute value parent function is y equals the absolute value of x. So those straight vertical bars, that is the absolute value function. And what absolute value means is distance from zero. Okay, so we're going to start by just graphing what the parent function is. So I'm going to put a few x values here of -2, -1, 0, 1, and 2, and find their corresponding y values. So if I'm talking distance away from 0, well, if I am at -2, the distance away from that, distance is never negative, so it's just the positive version of that. So the absolute value of -1, the positive version of that is +1. 0, the distance away from itself is, well, no distance, so that is 0. 1 is 1 away from 0, and 2 is 2 away from 0. So I have some points that I can plot onto this little grid here. And we could carry these on forever after, but our absolute value parent function comes looking just like this, right? We've got this one. Is what our graph looks like. Okay, so this is the graph of the function y equals absolute value of x. So let's look at a few things on that. We're going to start with our end behaviors. So as we remember, this first part tells us which way we're looking. So this says look on the left side. So when I look on the left side, that arrow is pointing up, so it's going to positive infinity. And when I look on the right side, that arrow is pointing up and it is going to positive infinity. Absolute value functions, the shape of it makes this V shape. Your end behaviors are going to be the same every time. The domain for our parent function is, well, how far to the left can this go? Well, this arrow there just tells me it's going to go that way forever. How far to the right can it go? Well, that arrow there tells me it's going to go right forever. So it is negative infinity to positive infinity. My range is the lowest it ever goes down to, which is here at 0. And it goes up to positive infinity. Okay. The axis of symmetry, or AOS as it might be called from time to time. Well, if you remember, symmetry means a line on which a thing can be folded so that they are the same. Here, my axis of symmetry comes right down the middle of this V shape. So for the parent function, my axis of symmetry is x equals 0. A thing to note, your AOS will be an equation. Okay, and it is x equals. Next thing we've got is our vertex. The vertex is that point right there where everything kind of comes out fourths, right? So in our parent function, the vertex is 0, 0. For our parent function, we have a local minimum of 0 at x equals 0. Okay. This is increasing, meaning it's moving up as it goes to the right from 0 to positive infinity. And it is decreasing, meaning as it moves to the right, it's headed down from negative infinity to 0. Because remember, the increasing and decreasing, that is dealing with x values that make the y values increase or make the y values decrease. Okay, so these are our basic characteristics of our parent function. Most of the time, we're not going to be dealing just with the parent function, but how it has moved and changed. So here we have our transformations that can possibly occur. So we have 4 main transformations, and we will be talking about these throughout the whole year. Right now, we're going to be focusing on 3, but I'm going to talk to you about all 4 of them still. So our first one we're going to deal with is A, okay? So out in front of the function, so let me mark where the function is. It's right here, right? It is these bars. That is our function. So the A value out in front, A's job is going to be a vertical stretch or shrink. Okay. It will be a stretch if that A value is greater than 1. And it will be a shrink if that A value is between 0 and 1. Okay. There is another thing that A can have. If A is negative, that means that there was a reflection over the x-axis. Okay, so that is A's job. It will do that for all of our functions that we talk about this year. The next one that we're going to look at is K. Okay, trailing on there at the end. K's job it will do vertical shifts. Meaning it will go either shifting it up or down. If my K value is positive, if it is greater than 0, then it shifts up. If my K value is negative, less than 0, then it shifts down. Okay. Next one we're going to talk very briefly about B. B, similar to A, is going to do a stretch or shrink, but this time it's a horizontal stretch or shrink. And everything inside of our absolute value bars kind of works a little backwards. So it will be a horizontal stretch if my A value is between 0 and 1, and a horizontal shrink if A is greater than 1. For right now, we are not going to be dealing a whole lot with B, so that can just kind of go in the back of your memories. One that we will be dealing with much is H. Okay, H is similar to how K works, but there's now a horizontal shift. Meaning it's going to move it either left or right. Okay. If you have inside of your absolute value bars X minus a number, that is going to shift it right. If you have X plus a number inside of there, then that will shift it to the left. I know that seems backwards from what you might think, because if it's plus, that should move it right. However, because the equation is minus H, that's where it goes opposite. Okay, so let's talk about how these transformations affect all of our graph characteristics. Our first one, the domain, well, it doesn't matter how this shifts, stretches, or shrinks, it is still going to be negative infinity to positive infinity for my domain. This is going to be the case always. For our absolute value functions, your domain is negative infinity to positive infinity. Okay, your range, well, your range is dependent on two things. The first one is your K value. That is one of the main things that'll depend on. The other one is your A value on whether it reflected or not. So whether it normal opening upward facing V, or if it reflected and is now a downward facing V. So if A is positive, if A is greater than 0, then our range is going to go from the K value to positive infinity. Okay, and if my A value is negative, if I did have a reflection over the x-axis, then my range is going to be from negative infinity going up to K. Okay, and I am using a bracket on those K values because our function does hit there. Our vertex, that point right there, that is what actually is shifting. So however it shifts up, down, left, and right, that is where our new vertex is going to be. So our vertex is the point HK. Remembering that in our equation, it's minus H, so we have to take the opposite of whatever we had. And we'll look at that when we look at our example. Our axis of symmetry, as I said before, it needs to be an equation. Okay, and that equation is x equals, because it is a vertical line that we're dealing with, and it is however it shifted left and right. So it's x equals h. Our end behaviors are dependent on how A had a reflection or not. So if A was greater than 0, then both end behaviors are going to go to positive infinity. If A was less than 0, if there was a reflection over the x-axis because A is a negative number, then both end behaviors are going to go to negative infinity. Okay. This also has in the same thing whether we have a maximum or a minimum. Okay, we have, if A is positive, then we will have a minimum, and it will be minimum of whatever that K value was, however it had moved up and down. If A is negative, A is less than 0, if it is negative, then we will have a maximum of still whatever that K value is, okay? So it's the K value. If you continue on with the where it happened, it's going to be at H. But this is our basics of how these transformations affect our graph characteristics. So we're going to look at a few examples here. So our first example asks us to give the transformations. So first transformation we have this negative out in front. Because A is negative, we have a reflection. Over the x-axis. Okay. The next thing that we have that is still associated with A is that number value. Now, when I said up here that if A is greater than 1, it's a stretch, and if A is between 0 and 1, it's a vertical shrink, what I mean is just the number value. As we see, that negative does its own transformation in doing a reflection or not. So I'm just looking at the numeric value of 1/2. 1/2 is between 0 and 1. Therefore, I have a vertical, oh, that was not the pencil. So I have a vertical shrink. And I say by what value? So it's a vertical shrink by that A value of 1/2. Okay. Next thing that I come across is my H here. Okay. So inside the absolute value, I have x minus 2. Nope, I guess I had that as purple. Let me change that very quickly. Okay. As it says right here, if it is minus that number, it is going to shift to the right. So this will shift right or move right. And by how much? Well, that number value is 2. Last thing we have is at the very end, K, right? That plus tells me that is positive. So it is going to move up by that number value of 4. So when we go to graph this, what is shifting is the vertex. So it moved right 2 and up 4. So that is where my vertex is now. So I can go ahead and label that as the point 2, 4. Okay. Now, for right now, you can think of your A value similar to slope. That's how we can count it. So it goes down 1 over 2, but it goes the same in both directions so that I still have that general V shape. Okay. So here is the way my graph looks on this. Because I did have an A value that was negative, my end behaviors, as it says here, if A is negative, both of them are going to go to negative infinity. Okay. My domain, I don't care what any of the transformations were. That is still negative infinity going to positive infinity. My range, because the A value was negative, it starts at negative infinity and goes until the K value, which was 4. My axis of symmetry is that equation x equals whatever the value of h was. So remember, our h, the equation is x minus h. So since I already have that minus, h is 2. Okay. Because a is negative, I have a maximum value of whatever k was. And if it asks us, it happened at whatever the h value is of 2. So the only thing that isn't talked about in here, in this part, is the increasing and decreasing. So for that, we're going to want to look at the graph most of the time. Yes, there are ways around that, but we're increasing from negative infinity until I get to that value there of 2. And then I am decreasing, starting at that value of 2, going off until positive infinity as it moves further to the right. Okay. Being able to look at the equation and pull all the pertinent information of our transformations and how that affects our graph characteristics is a big deal. We can go the other way as well in seeing the graph fully transformed and being able to piece it back to give us an equation. So that's what our second example wants of us. So it wants us to write the absolute value equation for the graph shown. So let me start by getting the y equals there and also getting that absolute value bar set up. Okay. First thing we look at is, does it open up or down? Because this V is facing normally, going up, we know that A is positive. So I don't have a negative there. What I do need to look at is to say, is it going from this point to the next point, did it have any stretch or shrink associated with it? Is the slope increase or decrease, or is it a normal 1? Here I can see it goes up 2 over 1, meaning that my A value did have a stretch pulling it up higher. So I start there with a 2. Let me actually make that same color as my A values have been. Okay. Inside the absolute value, I have X. And now I'm going to look, how did this shift left or right? Normally, my vertex would start here at 0, 0. But this moved all the way here to -3. That's where that vertex is, moving left 3. So to make it move left 3, I know 3 is the number there. To make it move left, that is going to be plus in there. Because really what it is X minus -3. But I can combine those two negatives to make it plus 3. And then lastly, figuring out how it shifted, if at all, up and down. So again, normally I would start here at 0, 0, but this one shifted down all the way to -5. To make it shift down, my K value has to go shifting down however much it shifted. Okay, so that is what we have when we're dealing with our transformations and a few examples of those. Again, if you had trouble with that, please go back, watch it, pause it as you need to. That way you can get this information down, and then you can ask questions of your teacher, either myself, Miss Wolf, Miss Lowry, Coach Loy, or Miss Hutzler, when you see them. All right, have a good one.